Hello, so today I will solve this problem question number 6 from AP Calculus BC 2007 Form B. So as you can tell, this question is generally about Taylor series. So we're given this function f of x, which equals that. And our first question, part A, is asking us to get the first four non-zero terms and general term for the Taylor series. So this f of x looks very similar to what we know, e to the x, and we're supposed to memorize e to the x. It's really important to memorize it. So, as you know, e to the x can be rewritten. The Taylor definition of e to the x equals this. So, we got the general form, and we have to derive this function, this Taylor definition, from this given the Taylor definition of e to the x that we memorized beforehand. So the relationship from e to the x and to 6 times e to the negative x over 3 is that you multiply 6 to the whole thing, right? And the x, the power, is replaced, instead of x, is replaced by negative x over 3. So all we have to do is times 6 to the whole thing, right? And then plug in negative, so in this case negative x over 3 to all the x's. So in this case, instead of x squared, it's going to be negative x over 3 squared over 2 factorial, and continue this procedure, and it will end up something like this. And we only need until the first 4 non-zero, so this is totally fine. And then we can clear this, we can make it cleaner by just expanding them, and we can rewrite that as this. So we got the first non-zero terms, and now because we have 4 non-zero terms, it's easy to get general term. So general term, there's no like easy way out or shortcut. You just have to get general formula using n and x, that in each nth term you will end up something like this. So when n equals 0, you will get this by plugging in to that general term, and when n equals 1, you will end up with this. N equals 2, you end up with that. So you want that kind of general term. So if you work throughout, you'll get something like this right here. So we've got 4 non-zero terms here, right? 1, 2, 3, 4, and the general term for the Taylor series of f of x right here. So part B, it says g of x equals the integral from 0 to x f of t dt, and we have to again get first 4 non-zero terms and the general term. So it's the same procedure, but we just have to be careful with the relationship of f of x and g of x. So he told us that g of x is an integral of f of x, f of t. So all we have to do is just integrate the first 4 terms we got here from part A. Then we will get g of x. But be careful, because if we integrate this, so okay, let's move on first. If we integrate that, we'll end up with something like this. And be careful, because it asked us for first 4 non-zero, and 100% sure this is not the first 4 non-zero, because there's x, right? The very first term of the Taylor series is always when you plug in the value to the function, right? So in this case, it's g of 0, And when you plug in 0 to x here, the interval is from 0 to 0, which is 0, right? So originally it will be like first 4 will be like this, but because the very first term equals 0, the first 4 is just the same as what we got. So in this case we were lucky, but usually maybe you will have some different value up there instead of 0, then you have to use that 3, include the first 4 including that, right? But in this case the very first equals 0, so the first 4 term will be this. And it's easy to get general term from there, and the general term you'll get will be like this. So basically what you did is just plus 1 to each end, most of them, right? Now let's move on to part C. So part C gave us the new function h of x and told us that h of x equals k, a constant, times f prime of a of x, and a is constant again. So we got two constants, k and a. And yeah, it told us a and k are constants. And they gave us the first few terms and the general term of the Taylor series of h of x. And all you have to do is find the value of a and k. So in this case, first what I'll do is differentiate f of x, because it gave us that the h of x is based on f prime of x, right? So let's get the general form. So this will end up being that. So because h of x is k times f of prime ax, we can rewrite this as negative 2 times k, right? Negative 2 times k e to the negative ax over 3. So this is h of x. So that's h of x. And we're given that h of x equals that, in terms of Taylor series, right? And that looks very similar, very familiar to us, right? It's the Taylor definition of e to the x. That's e to the x. So that means e to the x equals negative 2 times k times e to the negative ax over 3. We can say that, right? And then all we have to do is just solve for k and a. So basically there's no coefficient for e to the x, it's only 1. So k times negative 2 should end up being 1. That means k equals 1 over negative 2, right? And a, this negative ax over 3 should equal x. That means that a should equal negative 3. So in that case, negative 3, negative, that will become 1, right? Then x, so that becomes x. So a equals negative 3. So when we conclude, we can say the constant k equals 1 over negative 2, and a equals negative 3. Thank you.